Download this code from codegive.com, link in the description below. A deep dive into LUAC, compilation, usage, and disabled functions. LUAC is the Lua compiler, a crucial component of the Lua programming language. It's not directly interacted with in the same way you'd use an interpreter like Lua. Instead, LUAC translates Lua source code, .lua files, into Lua bytecode, .luac files. This bytecode is a more compact and faster to execute representation of your Lua program. Understanding LUAC is key to optimizing Lua applications and deploying them efficiently. Why use LUAC? 1. Performance * bytecode execution is significantly faster than interpreting the source code directly. This is because the bytecode is a lower-level representation already partially processed for the Lua virtual machine. 2. Protection * compiled .luac files are harder to reverse engineer than the original .lua source code. This offers a degree of protection against unauthorized modification or inspection of your code. 3. Deployment * distributing bytecode instead of source code is common practice for software deployment, particularly when you want to protect your intellectual property or reduce the risk of accidental modification. 4. Pre-compilation * compiling your Lua code beforehand, during build processes, can speed up loading times when your application starts. How to use LUAC *. LUAC is typically invoked from the command line. The basic syntax is *luac * the command to invoke the Lua compiler. The location might vary depending on your Lua installation, example /usr/bin/luac on Linux/Mac OS, or it might be in your Lua's bin directory. *options * various command line options control the compiler's behavior. Some important options include *o output _file, specifies the name of the output.luac file. If omitted, the compiler will output to standard output. *p, prints the disassembled bytecode to the standard output, useful for debugging and understanding how LUAC compiles your code. *s, strips debug information from the bytecode. This reduces the size of the .luac file and can slightly improve performance, but makes debugging harder. *l, lists the constants defined in the Lua code. *b, less common, creates a pre-compiled bytecode chunk that can be loaded into a Lua environment. *e, executes Lua code from the command line. This is less frequently used for larger scripts, but is helpful for testing small code snippets. *file name * the name of the Lua source file, .lua, you want to compile. If omitted and e is not used, the compiler will read from the standard input. Example *. Let's say you have a Lua file named myprogram.lua. To compile this using LUAC and save the bytecode to myprogram.luac. To then run this compiled code, you'd load it into the Lua interpreter. Disabled functions and code example *. Some Lua functions might seem disabled in the context of LUAC because they're not directly relevant to the compilation process itself. For example, functions that interact with the operating system, like io.open for file IO, or those that depend on a running Lua environment are not executed during compilation. Important note: *LUAC is only concerned with translating your Lua code into bytecode. It does not run your code, it only prepares it for execution. Any function call that has side effects, like printing to the console, opening files, or making network requests, will not happen during compilation. These actions occur only when the generated bytecode is loaded and executed by the Lua interpreter. Let's illustrate with an example that demonstrates the difference between execution and compilation. If you compile this with LUAC myprogram2.luac myprogram2.lua, the file output.txt will not be created. The print statement will also not produce output during the compilation stage. These actions only occur when you load and run myprogram2.luac using the Lua interpreter. Debugging compiled code ***. Debugging compiled Lua code is more challenging than debugging source code. You might need tools like a Lua debugger that can interact with the bytecode, or you may need to use the P option to disassemble the bytecode and inspect its structure. In summary, LUAC is a powerful tool for optimizing and protecting your Lua code. Understanding its usage and limitations is crucial for effective Lua development. Remember that LUAC's role is purely compilation. The actual execution of your Lua code happens when the generated bytecode is loaded into the Lua interpreter.